Okay, section 4.4, exponential and logarithmic equations. So two more types of equations. And we are getting close to the very end, very, very close to the end of the semester, end of college algebra. And going back to one of the fundamental things we did in chapter 1, equations. That your success in future math classes really depends on your abilities to solve equations and work with functions, since we're back to equations. Come the final exam, one of the things you're really going to have to be able to do is to look at equation, decide what type of equation you have, and then apply the appropriate techniques. We've studied linear equations, we've studied rational equations, we've studied quadratic equations, we've studied polynomial equations, and I'm sure I'm going to forget some as I'm up here. We've set polynomial equations, we've studied absolute value equations, I believe lots of different types of equations, and again, it's about identifying the type of equation and applying the correct techniques. So now we're going to have two more types of equations. These will be easy to identify. Exponential equations will involve exponents, where the variables are exponents, and logarithmic equations will involve logarithms. Starting with exponential equations. Exponential equations have the form a to the x equals b for a and b constant. In an exponential equation, the variable will be in the exponent. There are two primary methods for solving exponential equations. And I've just labeled them method 1, method 2. That's just my labels. Don't go searching YouTube videos for exponential equations method 1. This is just my labeling. Method 1, solving by expressing each side as a power of the same base. This hinges on this little fact here. If a to the x equals a to the y, then x equals y. So what this is saying, this says if two exponential expressions with the same base are equal, then the exponents must be equal. Note, this is not because the bases were canceled or because both sides were divided by a. It is because, there's another little typo, I should say it's because the exponential functions are 1 to 1. And hopefully someday I'll fix all these little typos. Now you don't have to remember why it is true. Like I said, it's true because exponential functions are 1 to 1, but sufficient to remember that if you have two equal exponential expressions with the same base, then the exponents must be equal. Before we can use this method, let's just review a few of our properties of exponents. X to the negative n equals 1 over x to the n, or 1 over x to the negative n equals x to the n. In words, negative exponents cause bases to move. X to the mn, x to the m raised to the n is x to the mn. For an exponential expression raised to an exponent, multiply the exponents. And our last rule that we'll review today, x to the m times x to the n is x to the m plus n. In words, when multiplying with the same base, add the exponents. Please note this method that is, gosh, we should really proofread things more. Please note this method that is about to be discussed won't always work, but when it does work, it is the easiest way to solve an exponential equation. It's sort of the equivalent to when we're solving quadratic equations. If an expression factored, that was the easiest thing to do, but not everything factored, so sometimes you have to do the quadratic formula. Same thing here. If this method works, it's the easiest thing to do, but it won't always work. So steps to method 1. Solve by expressing each side as a power of the same base. So step 1. 1, rewrite one or both sides as necessary so that you have the same base raised to different exponents, simplifying the exponents. 2, equate the exponents. 3, finish solving appropriately. 4, check. Good habit here to check, but if you did your work correctly, the answer will be correct. Okay, so let's do a problem. Solve the following. Okay, you're going to recognize it's an exponential equation because the variables are in the exponents. That's how we recognize that it's an exponential equation. So first thing I notice, or that we can notice, is that there is a very concrete relationship between 9 and 3, an exponential relationship between 9 and 3. And so I can rewrite 9 as 3 squared. And so now I'm going to have that same base thing. Then I'm going to simplify my exponents. And so I'm exponent to an exponent, exponential expression raised to an exponent. I multiply my exponents. And so I'm going to have 3 raised to the 8x plus 6. And now I have same base. That means that the exponents have to be equal. So 2x has to equal 8x plus 6. And then I just finish solving. And so negative 6x equals 6. Divide both sides by negative 6. And I get x equal negative 1. Now, good habit to check. Now you can check the old-fashioned way, and let's go ahead and do that. Check. We got x equal negative 1. So I got 3 to the 2x, 9 to the 4x plus 3. Let's put in that negative 1 and see if they're equal to each other. So what? That's going to be 3 to the negative 2. Wondering if that's going to be equal to 9 to the negative 4 plus 3. Or 3 to the negative 2. Wondering if that's going to be 9 to the negative 1. Negative exponents cause bases to move. So that's going to be 1 over 3 squared. Wondering if that's going to be equal to 1 over 9 to the first. And 1/9 equals 1/9. It checks. So you can check it the old-fashioned way. Or you can remember how we used to check, how we, in the past, just trying to, yeah, I can get everything on one page there, how we've checked things graphically. So the steps are up here, and so let's go ahead and follow those steps to check it graphically. So you set the steps are right there. You set the whole thing equal to 0, you press y equals, and you type that into your calculator. So 3 raised to the 2x minus 9 raised to the 4x plus 3. Now the little steps I have down here are for a TI-83. And 84, I don't think you would need. 84 doesn't do the little caret symbol for the exponent. And depending on, you probably on 84, and don't quote me on this, probably on an 84 you probably don't need the parentheses, but when in doubt, put parentheses. And let's just graph it now, and we'll see if the standard window works. Zoom 6. And so we don't see much of a graph, but we see enough of a graph. Graph it, we did, and we should find the x-intercept, and I'll zoom in on this. And for some reason we're not seeing anything over here, but we're not going to worry about that. It does look like we have an x-intercept at -1, so I feel good about my answer here. Life is good. Check it the old-fashioned way or check it with a calculator. I do have a y-intercept, or x-intercept, excuse me, x-intercept of -1. It checks. Okay, so there's the first one. Zoom back out. Let's do the next problem. Solve each of the following. Again, I've got all those e's, so I can make the bases, get them to be the same base. So doing one small step at a time. These are exponential equations, so rewrite that radical with an exponent. Square root, same thing as exponent of 1/2. Now let's do some exponent work. Recall, x to the m times x to the n is x to the m plus n. That I can add those exponents together. And so very, very explicitly, that's e to the 2x plus 3x. And then I really don't want that e in the denominator there, so let's call that e to the negative 1/2. Negative exponents cause things to move. And I needed that e to move, so I used a negative exponent. Then 2x plus 3x is 5x. Now I have the same basis, so I can equate those exponents. And then solve this. Solving any of your favorite ways, you could multiply both sides by 1/5. I prefer to clear fractions. That's just my way to do it. Clear the fraction. So I'm going to multiply both sides by 2. That is not the only way to solve this problem. So that's 10x equals negative 1, x equals negative 1/10. And you could check it the same way we did the other ones. You could either check it by hand, or you could check it looking at a graph. But on these guys, checking is optional. If you did your work correctly, the answer will be correct. Okay, one more of this nature, and then we will move on to method 2. Okay. There is not a direct relationship between 25 and 125, meaning I can't say 125 is 25 squared or something like that. But they both contain a relationship to 5. 25 is 5 squared. And 125 is 5 cubed. And I'm going to rewrite that exponent that way. Simplify the exponents. Exponents to exponents, we multiply. So that's going to be 5 equals 2x squared minus 3 equals 5. And here, I'm going to write this a little bit neater. Just a little bit neater so we can see it better. That this exponent was 15x plus 2 over 3. When I multiply these exponents together, those 3's are going to cancel. So I have 15x plus 2. And now I have the same base on both sides. So that means the exponents must be equal. And now I finished solving appropriately. I see that x squared right there. That tells me it's a quadratic. That's not how you spell quadratic. So you run through your choices of quadratics, the two most popular, factoring or quadratic formula. Both of those require me to set it equal to 0. So I'll subtract the 2 from both sides. Then I'll move the 15x to the other side. And then we try to figure out what to do from there. You either think about factoring or the quadratic formula. If you're not good at factoring, go to the quadratic formula, or if you just don't see the factoring, go to the quadratic formula. And I really don't think this factors, so we'll go to the quadratic formula. That's because I made a mistake. Let's go back and fix my mistake. And tell you what, I'm going to end this video and we'll fix the mistake on the next video. So hit cliffhanger, finding the mistake. End the video, find the mistake on the next video.